Assalamualaikum warahmatullahi wabarakatuh and a very good day to all the panels. My name is Badrul Amin bin Badrul Hisham and today I'll be presenting my final year project proposal presentation on the topic of stability and power resistance of a tourism boat. So let's start with the introduction. What is nautical tourism? Nautical tourism combines boating with vacation and holiday activities. The most commonly used vehicle in nautical tourism is the tourism boat. A tourism boat must be safe and efficient to ensure the safety of all the passengers and reduce usage for the tourism company. Lately, multi-hull vessel has gotten great attention in nautical tourism. We can see multi-hull vessel being used for tourism such as island hopping, sea cruising, and many more. Multi-hull vessel have proven its advantage in many applications, and finding out its main criteria for its advantage is important to show the significance of this hull design. The most popular multi-hull vessel currently is the catamaran vessel for tourism. The catamaran vessel is a vessel that has two separated hulls and its deck in the middle, as you can see in this picture up here. Continuing on to the problem statement. The first point is on the safety of a boat or a vessel. Stability is the main point in safety for a boat or a vessel. It is critical that the vessel maintains its stability in both calm and violent seas. Critical on tourism boat as it dictates the safety and comfort of the passenger. Finding the difficulty of a boat to capsize instability directly affects the safety of a boat or vessel. Second is the powering of a boat or a vessel. Vessels such as tourism boats with motion through waters requires energy to overcome the resistance. In example, the force working against movement, with some using excessive energy source to provide the necessary propulsive power to overcome this. Finding the resistance that is acting on the tourism boat will directly help to determine the energy needed to power the tourism boat of a specific hull with its numerous loads from passenger efficiently through calm waters. Lastly is the comparison between the multi-hull vessel and the conventional single-hull vessel. Since multi-hull vessels design picking up in popularity in many applications, to prove the improvement of this hull design is important. The multi-hull design will be compared to the normally single hull design in terms of tourism. Okay, we'll continue to the objectives of this project. The objectives that will be achieved by the end of this project are as follows. First is to determine the effect of the hull design in the stability and power resistance of a tourism boat. Next is to analyze the data for safety and powering of tourism boat. For the literature review, there will be two main points that is critical for this project, which is power resistance and stability. The previous study that was reviewed has similar points in terms of power resistance and stability, but with the different hull designs including multi-hull designs and single hull designs. The first point is the power resistance. What is power resistance? Well, resistance occurs in ships that move through the water medium at a specific speed in the opposite direction of the ship's motion. A ship's resistance is affected by numerous elements. Some of it are wet surface area, speed of the ship, and the type of fluid. This force is caused by direct contact between the hull shape and the fluid. In this case, the multi-hull design vessel and water at the sea or river. The resistance of a vessel is denoted by the unit Newton. The second point is the stability. Stability refers to a ship's ability to return to its position, to its original position, after being tilted by pressures from outside and inside. Stability directly determines the safety of a vessel. The length of the righting arm is used to determine whether or not the ship's stability is accepted. The length of writing arm is also called GZ. For the scope and limitation, I'll be going for the scope first. So this simulation will be conducted on a naval architecture analysis software called Polycat. It has many features, and one of them is on analyzing its resistance and its stability. Since this study is a correlation between the design of a multi-hull tourism boat, specifically catamaran tourism boat, and the stability of boat with its resistance, the hull design will be simulated in this project is the catamaran vessel. The load and speed of the vessel will also be considered to ensure accurate prediction of result in real world. Going for the limitation, with this project, finding a hull specification of popular catamaran vessel from models such as Entrance 441, Atlantic 42, and many more are difficult and not readily available because of the design company or manufacturers don't want to. So to continue this study, the hull specification will be taken from previous studies and modified into tourism vessel. Another limitation is that this simulation runs under perfect theoretical condition, meaning that there is no external forces that will affect the simulation such as wind resistance and waves. Moving on to the methodology of this project, I start with the literature review. In this, I gather data and information on related topics to this project. After that, we've moved on to parameter selection. This parameter selection is for the specification of the vessel. From its length to its rod will be selected here. With the parameter selection of the vessel specification done, we will design the hull model following the vessel specification. Then another parameter selection will be done. This is for its parameter that is not directly affected by the design of the boat, such as its weight, of the load, and speed. With all that completed, the simulation will be conducted. If there is inaccurate result or there is a problem with the parameter must be reviewed and improved and also continue the flow until the simulation are adequate and accurately presented. So this is the 3D model of the vessel or boat, the catamaran vessel. So the specification, it has the length of 7 meters with a breadth of 5 meters. The depth is 1.1 meter and the draught is 0.45 meters. The draught is the depth of the vessel that is submerged in the water. So this is the expected results. There will be two data that will be gained from this simulation. The results of the final simulation will be similar to this, only the model will be different. The first data will be the GZ curve graph for the stability of the hull. The graph will depict the writing arm GZ in relation to heel angle. The higher the GZ relative to the heel angle, the better its stability. The writing arm GZ is the distance between the forces of buoyancy and the center of gravity of the vessel. Heel angle is the rotation of hull going side to side. The second data will be the total resistance against speed graph. This will show the resistance the hull endures under movement of specific speed. This data will be used to find suitable power for the hull to overcome the resistance. As you can see in the graph right here, there is a dip in the resistance line near the 8 knots of speed. Uh, that is called hollow in nautical terms. This is the area that we want to find the most, as it is the most efficient in terms of for the vessel, in terms of the least resistance that the vessel is enduring with its most speed. So in conclusion, a design of a ship hull plays an important role in affecting the stability and the resistance of the boat. Both of these criteria are important for the safety of the boat and the powering, especially in vessel use in tourism. This project will help to show the safety and efficiency in stability and powering of a multi-hull tourism boat. That's all from me. Thank you very much. For any inquiries of this presentation of this project, You can contact me through WhatsApp and Telegram with the number on the screen. Again, thank you very much.